Hello everyone. Welcome back to this stage of SLUGME 6, 24-hour-long event. It's great to have you back here. We've entered stage UTC-11, which is the time zone that American Samoa is located in. We're about 13 hours into this journey, which is unreal. Can you believe it? So if you've stuck in it so long, just congrats, way to go. For this segment here, I am Ivan Lowen, and I will be your crew chief. Our driver today is none other than Alin Vargatu. I'm so excited to have him on board. He is a SolidWorks champion. He is well known in the SolidWorks world. He is an excellent presenter, the best at his job, and he's often presented at SolidWorks and 3D Experience World. I think you will really enjoy what he's got. You know, just like the Le Mans 24-hour race, this 24-hour SLUGME event is one that requires endurance and skill. Now, the endurance, do you have what it takes to watch the whole event through? I don't know. We'll just have to wait and see. I've got some coffee here. Oh yeah, that's good. That's going to help out. As for the skill, we like to find the best drivers, and this is simply the best driver that I could find for this event. I want to give a special welcome to anybody that may be in this time zone watching from American Samoa. And I don't know anyone personally from there, but if you are located there right now, please enter the YouTube chat and let us know. We'd love to hear from you. This goes with anyone else that's watching. If you have any questions, any comments, feel free to enter the chat. I will be in there, Alin will be in there, and we'd love to chat with you, answer any questions you may have. So, with that, I'm hearing from Alin. I think he's about ready to go. He has got both hands on the steering wheel. So, there's a light. Take a look at that. When that thing turns green, I think we're ready to take off. Ah, there it is. There it is. Folks, ladies and gentlemen, sit back, buckle in, enjoy the ride. Take it away, Alin.
Roger that, Chief Ivan. I'm your driver, Alin Vargatu from Javelin Technologies, a Trimec company, and I'm honored to drive for the next 45 minutes on behalf of our SolidWorks friends from the American Samoa. For those of you who don't know, we are very close to the international date line. So you can see it right here. I am ready to go. As you can see, my engine is red, which means, ouch, this is very hot. So let's have a lot of fun in the next 45 minutes covering some of the most interesting case studies dealing with multibodies. And it's all about saving time or saving the day. I selected 8 gems from my treasure box that I'm going to share with you in the next few minutes. The agenda is very short, a little bit of theory before, because I'm always surprised how even power users sometimes confuse features and bodies. And then we're gonna talk about some of the most powerful techniques for saving time, or sometimes even saving the day when you are in a hurry and you need to get the job done. So features versus bodies. At one of the past SolidWorks Worlds, I attended a presentation done by Monica Menghini from SolidWorks, and she said that in the age of experience, design is the vision and shape is the result. The following day, I was supposed to present something about multibodies, and I was thinking, you know what? What she said can be changed into, in a SolidWorks model, the feature is the vision, and the body is the result. So feature is the information that you put in the model, and SolidWorks kind of follows your instructions, your features, in order to create the bodies. Another way to look at this is thinking about baking a cake versus buying a cake. So features are pure information, right? They are the recipes. This is what you need to do in order to bake the cake. I'm not a baker, so I don't have recipes. I don't follow recipes. What I do, I go to a shop, a bakery, and simply buy the cake. It's the body. I don't really care how it was created. I know it's yummy, and that's all it matters. So in the feature manager, features are just instructions, bodies are the geometry, the result. Now, how can we use this in order to save time? So let's take a look at case study number 1. What I have here, it's a Lego piece. And my son wanted this other Lego piece. Now, if we are to 3D print this, I don't have a model for it, but I had a model for this one. So I asked him, okay, what would you suggest me doing? How should I go from here to there? I don't have any features, any instructions. It's an imported body. And what he said is, why don't we cut this, split it, and move it further out, and then just fill the gap inside. Now it's time to divide and conquer. As you can see, I have only one solid body in this part. So what I need is to split this body in two and then move one of them in the position that I need. To split a body, I need a splitting tool, like a saw or a wire cut pad. That can be done with a sketch, can be done with a surface, or can be done with a plane. So let's use a plane in this case. The other thing you're going to see me doing is working as much as possible in the graphics area. I don't want to go to the feature manager. I don't want to go to the command manager. So I'm going to pre-select this face. I want a plane that's tangent to this face and also this face. I want the same plane to be perpendicular to this face. And notice I promoted the plane command to the context toolbar. So whenever I select faces, SolidWorks knows that maybe I want to create a plane, gives me this option. And guess is almost right. The only thing I need to do is to flip the offset for the tangency. And with that being said, we got our plane. I'm going to use the direct editing toolbar to do most of the work. So let's start the split command and use this plane to cut the part. It's not really cutting the part, it's going to split the part. Let me click OK. And you can see right now I have two bodies where before I had only one. Allow me to hide the plane. We're not going to need it for the time being. And let's do another thing. I don't need to know about features. I don't need to recreate this feature from scratch. I simply need to move this body in the correct position. Allow me to go back to the instructions. Notice this needs to be rotated 180 degrees and translated 5 millimeters. So let's do exactly that. Move body command. Move body has two flavors. Translate and rotate, where you can select the body and move it in the direction that you want, or you can rotate it in regard to a certain axis and the number of degrees, or constraints, which are very similar to mates in assemblies. So let's instruct this body where to be. I want this face to be coincident to this face, but I want them to be flush, so let's change the mate alignment. Let's add this instruction. Notice I'm calling them instructions, not mates. Let's select this face and this one and apply a distance of 5 millimeters. And then simply make these two faces flush and add this instruction and then finish the command. So you can see right now where I am. We started in this position and now we are here. Just be aware there is a little bug in SolidWorks that is related to applying this type of distance mates in the body move copy command. If I do a force regeneration, which is Control Q, notice how this fails. Fortunately, there is a very simple fix. You simply need to edit that one more time. So you know what I'm going to do to this distance? I'm simply going to delete it. And also to make my selection easier, I'm going to change one of these coincident to a distance. Okay, so that's for the time being, this is going to be a distance. That allows me to easier select these two faces. I'm going to go back to 5 millimeters and take the first distance and turn it to coincidence. There you go. All the instructions were recreated. Let's do another force regen, Control Q. This doesn't fail anymore. This is a known problem. I'm going to give you the SPR number if you would like to vote for fixing this sooner rather than later. Now let's copy this. Remember, we need one more copy of this. Unfortunately, I cannot copy this body as long as I'm trying to apply constraints. So let's move to the other flavor of the move body command called translate or rotate. And now you can see I have an option here to make a copy of this body. If I just simply click OK, another body is going to be created on top of the other one. But just to show you what happens, I'm gonna move the copy out of the way so you can see the clone that got created by this. And let's add one more command, one more move body feature. And for that, I'm gonna switch back to constraints. I'm gonna get this body to have this face coincident to this face, and this face also flush with this face. So allow me to change the alignment and accept this new position. Let's compare what we have on the screen with what my son wanted. It looks like we need to bridge this gap, right? He would like to have all this welded together. I have three bodies, as you can see here. One thing I'm going to do, I'm going to create a sketch on this face. Notice that this face is already selected, so I can use the shortcut toolbar. I press the S key, convert entities. I'm getting my edges, press S again, and extrude. How far away should I go? So let's take a look at some of the options. Probably a good one would be up to body or up to next. Let's go up to next. Also very important is, do I want this new geometry to merge the existing geometry? Whatever gets touched gets merged into one body. And you can see here the option to do that, merge result. Also, I can specify what exactly is going to be merged to the new body. So let's say everything is going to be merged to that new piece of geometry. And you can see I got the result I wanted. Now, I don't know about your customers, but this particular customer is very demanding. He wanted now this piece. So the question is, how do I go from here to there? Well, there are a couple of things I can do. I can go back in time before I bridge this gap and mirror this body to the other side. But one thing that would be also interesting to find out is, when I started with this, is this part symmetrical? So I don't know if you ever tried, but we have a great tool here called Symmetry Check. So allow me to select this face and this face. And also it works to check if the entities on the part are symmetrical in regards to a plane that would be located in the middle of these two faces, kind of the symmetric position. And you can see I'm getting everything green, which means everything was symmetrical. The other thing about the symmetry check, a plane actually gets created in this location. So now I know that if I come back to the present, I can simply take this plane and mirror the whole body, not the features, but the whole body about it, and then merge the new resulting solid with the old one. And you can see the job was done. So just a couple of features and we are good to go. Let's take a look at the next case study. And by the way, this is the SPR number that I suggest you ask your value-added reseller to add you to the notification list of. So hopefully it's going to be fixed sooner rather than later. And this is the workaround that I mentioned earlier. Let's take a look at the second way of using multi-bodies to save the day. So I'm going to open up the next case study. I have here one body and I would like to apply a fillet. Let's see what fillets we can apply. Let's start with the 1 millimeter fillet. Looks like it works fine. Let's try 2 millimeter. Works. 3, 4, 5. You can see how this geometry over here becomes harder and harder to compute by SolidWorks. Let's go to 6 and no preview. So if I click OK right now, it cannot apply a 6 millimeter fillet. So what can we do? So always think about divide and conquer. Let's examine how this body was created. What instructions were used? Remember, features are pure instructions. Looks like we started with an extrusion. We added a fillet on the top face. Then there was a line here that was used just as a reference for creating this plane. Now we have this plane, and the last feature, simply, it's an extrusion up to that plane. As you can see, the sketch, it's on the bottom, up to the plane. But remember from the previous example, we have an option to say, create your own body, man, don't merge to the other one. So now I have two bodies, body 1 and body 2. I can hide one at a time. So by the way, a quick tip, if I want to hide one of the bodies, I simply move my mouse over it and press the tab key. I want to bring it back, shift tab. right? So notice tab, this is clear, it's a body on its own. I can very easily add a fillet, 6mm fillet, and it worked. Now let's bring the other one back, shift tab, so now both of them are visible, but I would have to combine them together. So again, under direct editing, you have the combine command, use the option to add, select the two bodies, add them, and now I have one body instead of two. And just to prove how amazing this is, I'm going to add a fillet here, same radius, and it worked fine. So remember, divide and conquer. It's a valid and very useful technique. Let's talk a little bit about another tool that works with bodies. It's called Intersect, and it's fantastic. It can replace many other features. So you can see it can replace all these things and a few more. So let's see how this works. Currently I have here a solid body, is this cylinder, and I have this surface body. Looks like a sombrero hat, right? So notice they're independent of each other. And what I would like to do is to fill the space between this part of the sombrero hat and the cylinder, and also remove the space that is above the sombrero hat. So any geometry I want to be removed from there. So the tool for that is going to be Intersect. I'm going to select both entities. Intersect accepts surfaces, solid bodies, and planes. And it's looking for regions that are being created by, are completely enclosed in this, inside the faces and the planes and the surfaces that you selected. So you can see there are three regions, region 1, region 2, and region 3. If you want to remove one of them, or more than one, you can simply select it. And you can see it gets a check mark here. And also at the bottom of the property manager, I have the option to merge the result. So you can see with one option, I can get the job done. I can do even more with one feature. I can remove the reference surface. So I can use the option consume surfaces. You can see the end result is just a body. Now, this is a simplistic way to use this tool. Let's see if we can find really good use cases for it. And probably one of the best is simply making some money. For a bet, you can make a bet with your colleagues who might not have attended this presentation, saying, hey man, can you create a solid body without a sketch in SolidWorks, starting from scratch? And if they say no, I say, I'm gonna bet you $1 or whatever currency you want to use, that is possible. So let's see how this works. Let's start with the simple part. I'm just gonna make this, the major planes visible. And let me copy a couple of them. I'm gonna use offset command for the planes. So one quick way to do that, you select a plane, hold Control, drag it, and you simply create another plane. Let's try to do the same thing for this guy. Control, drag it. And the last one, Control, and let's drag it down. So what I have right now, it's a space that most likely is completely enclosed by this plane. What's a quick way to select all the planes? You might wonder. And it's the same thing that would happen if you hunt with a dog. So I give the dog the scent and it's going to find the prey. In this case, I select the plane, I press Ctrl A and selects all the other planes. Okay, so let's run the intersect command with these planes, and you can see a solid body got created at the intersection of those planes. Now, this is a little bit of a gimmick. Let's go to much more serious stuff. A very common use case is you have something that should have a cavity, even though it has some openings to the outside, and you're wondering what's the volume of that cavity. You need to fill it, right? So let's give it a try. I have here a volute pump, and the first thing I need in order to use intersect is to seal this gap. So we're going to create some leads. One great tool for that is the planar surface. So if you have planar edges, you can actually select them. Allow me to use the magnifying glass here. I'm going to press the G key to select this edge, and also over here to make sure I'm selecting the right edge. Right? So there you go. One feature created 3 surface bodies. So again, we're talking about bodies. Now, what I want is to create the volume that's completely enclosed in there. So let's run the intersect command. This time, I'm going to ask those to create internal regions. So I'm going to select everything and simply fill the volume inside, fill the cavity with something. Let's see what we get. You can see the volume got created. A new body gets created. So if I go into the solid bodies, I can see, okay, that's the one. Let's isolate it so we can see just this specific body. And even more, let's give it a certain material. What would we like to do here? By the way, in SolidWorks 2021, you can even search for a material. I'm going to search for water, and I'm going to apply it to this body. So now if I want to calculate what is the mass, what is the volume, no problem, works fine. Okay, so you can see the wonders of the intersect command. Next example, intersect versus combine. So what I have here, I want to create a knife with no cutouts. I don't want to use a cut feature, extrude cut. I don't want to use extrude revolve cuts. I don't want to do anything. I simply want to take existing bodies and use them to modify other bodies. When I finish with it, the part is going to look like this. It's a multi-body part. Right, so you can see here I have the blade. I have for each, the handle is in two halves, and I have 3 pins. One thing that's important about the pins is to be shaped in such a way that they match the complex shape of the handle. Now, in the past, I did that with combine commands, and you can see it's pretty complicated. Allow me to suppress all this, and let's do it again. Let me isolate them one at a time. So you can notice this is the blade, this is the handle, and it doesn't have holes. It's one body, and these are pure cylinders. Let's start with shaping the pins. So you might think maybe you can run combine using the common option. Select the handle, select one of the pins, and you can see how SolidWorks maintains only the volume that was common. This way you get the end faces to be the shape that you want. The problem with this is that both bodies get consumed by the combined common operation, so that would not be acceptable yet. What we need to do is to clone the handle 3 times. So let's go to the copy bodies command, increase the number of copies to 3, select the handle, and click OK. So right now I have 3 clones of the handle. Let's run the combine command, this time with common, select also the pin, and let's click OK. See what happens. You can see how one of the copies of the handle gets consumed along with the old pin, and I'm getting the shape that I wanted. Let's do it again. Common between this and this. Let's see if I press enter, what happens. You can see how the enter repeats the last command, so that's going to save me time, right? And the job is done. We have the handle, and we have 3 pins. Now I would like to remove the 3 pins and the blade from the handle. So similar to what we did before, we need to make a copy, not of the handle, but of the 3 pins and of the blade. So now I can run a combine subtract. I can subtract from the handle the copy of the blades and of the pins. And you can see how this is going to split this into, and SolidWorks even asked me which one I want to keep. I want to keep both. If I'm isolating these 2 handles, you can see that they are done. I don't need them anymore. We're good to go. Let's hide them. Because we need to do one more thing. We need to subtract these pins from the handle. So again, I need a copy of them. So let's run the copy command. Make a copy of these 3 pins. And subtract these 3 copies from the blade. 1, 2, 3. Now we're good. Let's bring back the handle, Shift Tab, and you can see if I'm isolating the blade, it works fine. If I'm isolating the pins, they have the shape that you want. And with the handle, we already know. The problem with this, it was a very cumbersome process. I'm pretty sure many of you fell asleep just by watching me doing it. So allow me to delete all these extra features. And let's see if Intersect can do the trick for us. So I'm going to run the Intersect tool. I'm going to select everything. And I'm going to ask SolidWorks to intersect them. Now, what exactly do I want? I would like to remove these areas, these regions. And everything else I don't want to be merged. I want them to be kept as separate bodies. Okay. Now, if I'm looking at the two handles, let's isolate them. They look fine. The job is done for the handle. Let me hide them, tab and tab. The blade is actually made in two pieces, so we need to either run combine add, or if you want, you can even run intersect between these two. And you can see here at the bottom the option to merge the result. So this turns into one piece for the blade. Let me hide the blade now. And you can see how each pin is made out of three pieces. So if you want to run combine, you need three combined features. Let's see what intersect can do with these 9 bodies. So one thing that it can do, it can recognize them as separate regions, but also it's giving you the option to merge everything that is possible to be merged. And you can see how in 3 features I was able to get the pins, the 2 handles, and the blade. So intersect save us a lot of time. Let's take a look at the next example. In this case, we will use multi-body techniques to reverse engineer the shape of a model. This came from a real life case study. I helped a client of mine who has a 3D printing shop. He received a model of a very complex camera from one of his customers. Unfortunately, I cannot share that with you, so I created my own model. He 3D printed that camera and it came up with a number of cavities. His customer told him he actually wanted these cavities to be filled in such a way that the outside is flush with everything around. Just use a different material because that's where he's gonna have the lenses. So the question is, how can we reverse engineer something like that? Let's see. Let's open the example. You can see it has these cavities. So the first thing I'm gonna do, I'm gonna make a copy of this body like we did before. So let's make a copy of it. And let's hide the original. So I'm gonna go here, I'm gonna hide the original body. I have just now a copy. What I want to do is to get SolidWorks to remove all these cavities and revert to the original shape. And fortunately, that is possible using one of the direct editing tools called Delete Face. Delete Face has 3 flavors. The one I'm going to use is called Delete and Patch. And you can save a lot of time selecting the faces you want to delete by simply selecting one and then using the context toolbar to select, in this case, all surrounded faces. You can see I can go click, and I'm selecting tens of faces with just a couple of clicks. What Delete and Patch does is not just removing these faces, but also healing, if you want, their neighbors, the surfaces around, back to their original shape. Let's see the result. And you can see it worked fine. Let's bring back the original body. And you can see I have 2 bodies, one on top of each other. And you probably can guess what I'm going to do next. I'm going to run the intersect command between these 2 bodies. And I'm going to ask SolidWorks to not merge the results. So now every region is going to create its own body. You can see this is the original. Allow me to isolate it. Now let's go and hide it. And you can see I'm getting the lenses. Just apply a different material and the job is done. So a nice way to save the day. When my son was 1 day old, I get to use this device, and one of the things I was wondering is, how can I measure the volume that can go inside it? And also, how much milk or how high the milk is gonna raise if I want to pour a certain volume. Let's find out. With this Intersect, we already know it's very easy to fill a bottle. We just need the plane for that. So let me take the top plane and do an offset. Remember, control drag does that. Let's start with maybe 2 inch. And ask SolidWorks to fill this bottle up to this plane. So again, intersect, use the option to create internal regions. I don't want to split the bottle, I just want to fill the bottle. Intersect, and you can see that has been filled. Allow me to hide the bottle for a moment, and you can see right now I have the volume of milk. How do I measure it? So there are a couple of ways to do that. One is with the mass properties. Just make sure that instead of selecting the whole part, you select the actual body that you want to measure. And you can see right now the volume is about 3.8 ounces, and I want exactly 3 ounces. Of course, I can double click on the plane, pick up this dimension, adjust it, measure again, and keep repeating all that work. That's very, very time consuming. Even better, I can get the volume reported as a sensor. So I can go to the sensor. So let's add one related to the volume of this body. And you can see right now, if you go here, the volume is 3.818. So now it's just a matter of varying this dimension and rebuilding to read the volume. Fortunately, there is an even faster way to do that. I can simply add a design study. If you have SolidWorks Simulation Professional, you can even use the optimization option to find the actual result. If not, you don't use the optimization. So let's try with optimization first. I'm going to add as a parameter this dimension. Let's call this level, the level of liquid. And let's make sure that we specify some ranges. We know 2 inches is too much, so why don't we go between 1 and 2 inches? Let's use the option ranges with step. So a step of 0.1 millimeter. Now, what is the goal? The goal is for the volume to be exactly or as close to 3 ounces as possible. And now let's run. And you can see how SolidWorks, it's simply changing that dimension and is measuring the volume. And the beauty of using optimization, it's automatically selecting what is optimal. So now if I want, I can further refine this. I can go to the variable view and say, you know what, looks like 1.6 is a bit too much. Why don't we go between 1.5 and 1.6 with a step of 0.01. Let's run this again. And hopefully it's gonna find something that's even closer to 3 ounces. Looks like at 1.59 I'm getting exactly, I'm inside 2 decimal points. If I select this and I go back to the model, this is actually the value that is gonna be preserved. Now, what if you don't have SolidWorks Simulation Professional? Well, in that case, you wouldn't be able to use optimization, so you need to take it out. And you cannot use goals, so I'm going to have to delete this goal. Okay, so turn off optimization. You can stay with the range with step, 1.5 to 1.6 in this case, and you can add the volume as a constraint. So the only thing you can say here is just monitor it. Give me a list of what's going on there. So very similar. SolidWorks is going to go through all these scenarios. It's not going to pick the optimal one for you. You're going to have to visually take a look which one is the closest to what you need. So it looks like it's 1.59. Select the scenario. This is actually the value that's going to be listed in there. So nice way to save a lot of time by having SolidWorks do the iterative work for you. So far we ran the Intersect tool inside parts. What about assemblies? In this case, I have an intake manifold, and I'm curious how much gas, how much air it contains. So let's find out. This is the assembly, If I do a section view through it, you can see that there are cavities, actually areas that communicate through the manifold. Also, I have quite a few parts. If I'm checking the performance evaluation, I can see that altogether there are 17 components. I cannot run intersect inside an assembly. So what I need to do is to model the gas as a part. So let's try that. I'm going to insert a brand new part, and I'm simply going to click on the empty space in the graphic area. That ensures that the new part I created is placed in the origin of the assembly. So notice the origin of this new part and the origin of the assembly are the same thing about their planes, like from plane and from plane, right plane, top plane are going to be one on top of each other. Also, the new part is fixed. Allow me to rename it. I'm going to call it gas. And notice this is a virtual part, it's between brackets, so it doesn't yet have its own file. Maybe I don't even need a file, I just want this air or gas volume to be inside the assembly. Let's edit this part. Right now it's empty, right? If I open this part on its own window, you can see there is nothing inside it, absolutely empty. Let's switch back to the assembly. I'm in editing mode. One thing I would like to do is to copy all the bodies of the assembly inside this part. So that can be done with a feature that is available only when you edit a part inside the assembly. That feature is called join. You can also search for it instead of just going through the menus. So allow me to select everything. One interesting thing about the join command, it can even merge the bodies of the parts you selected together inside that new part that I created. So let me click OK. Now let's see the result. If I open again the so-called gas part and I do a rebuild, you can see how everything that was in the assembly, geometry, all the geometry of the assembly got copied in here. This is also has another major advantage. If the parts inside the assembly will change later on, this will update. You can see here it has external references. So if I'm doing sections here, you can see again the cavities. Right, so nothing different than what I had before. What I want are actually is the space inside the cavity to be represented as a model, not everything else. So let's prepare our model to accept the intersect tool. Let's start with applying a plane here. Of course, I can use the planar surfaces like we did before. So let's simply put a 0 millimeter. I think we are in millimeter displacement. Okay. Let's apply another plane right at the bottom. So instead of applying multiple planar surfaces, simply I'm gonna go and create another 0 millimeter offset plane from there. So there are two planes and one solid body. Time to run the intersect command. Plane 1, plane 2, solid body. This time, I'm gonna ask SolidWorks to create all the regions. I don't necessarily want just the inside because I want to automatically delete everything else. So which one do I need to keep? Notice I have altogether 8 different regions. Well, I know this is the one I want to keep, so allow me to simply click on it just to see which one is selected. It looks like is region 1. And then let's use the invert selection option to mention that I want to preserve this and get rid of everything else. So invert selection and simply click OK. And you can see this is the volume that I require there. One thing that would be probably a good idea is to apply a material. So let's apply maybe air as the material. And at this point, we can identify the volume, we can identify the mass. So let's calculate that. 8.8 liters. If I switch back to the assembly, notice that the volume of gas is there. If I do a section view, and I click here, this belongs to the gas. So it worked fine. It worked. The last case study, it's even more interesting because this time we will have also an assembly with two parts, and we need to create a dampener between these two parts. So imagine these two are both metal and they are touching and they make a lot of noise. So let's open the assembly and let's take a look at it. Part 1 is the yellow one. You can see how it looks like. Part 2 is the red one. There is a problem though. If I'm trying to use the same technique that I used in the previous case study, notice there is an opening, there is a gap between the two parts. So you wouldn't be able to run intersect if you have this gap. The material is simply going to flow through there. It's going to go out. So the technique is going to be, again, divide and conquer in 2 steps. Let's insert a new part in this assembly. That's going to be the dampener. So very similar to what we did before, insert a new part, and I'm going to put it in the origin of the assembly. Let's call this exactly that, dampener. And let's edit it directly in the context of the assembly. This time, I'm going to copy only the body of the red part. So let's try join command. This time I'm going to try to search for it. Okay, so SolidWorks can find it, select it, and simply copy it inside the dampener. Now if I open the dampener, you can see it contains this part. What we need to do is to create some type of interference between this part and the yellow one. So I need to move some of these faces to create this interference. And I calculated that 4 mm is going to do the trick. Let's go to the direct editing and run the move face command. I'm going to type here 4 mm for the amount of translation that's going to happen. And I'm going to say I need this face to move, and also all the faces that are tangent to this one. So you can see these are going to go. The question is what's the direction that I'm going to use. So allow me to select this face to provide me the normal to this face as being the direction. Also, I need to go and add these faces. So this one, and also the ones that are tangent to this. Yep. So you can see the result in the end. This is what was before the move face command. This is what's happening after the move face command. Let's switch back to the assembly. And let's examine what's going on in this area. Maybe I'm going to exit for a moment from the edit part command. So you can see I have interference between the dampener part and the yellow part. Let's edit this dampener one more time. And let's add the body of the yellow part in here. So again, join and click OK. And you can use more than one join feature. So let's open the dampener. And you can see right now I have both of them actually fused together. It's only one body in there. But if I decide to do a section view, you can see that there is a gap. And actually this is the gap that I want to fill with a material like rubber. So it's going to dampen the vibration. Unfortunately, if you try to run intersect with only one body, you're going to find out that's not possible. Intersect was originally considered that it's going to require at least 2 entities. So let's add a plane just to have it in here to get access to the intersect command. Run the intersect command, and SolidWorks is going to find all the regions that are located inside the various faces of that body, and obviously the top plane. Let's see what we're gonna find. Right, there are quite a few regions here. There are 8 regions. Let's find out which one we actually need. So allow me to remove the one that's on the outside. Looks like we need this one. So looking at this regions, region 8 is selected. That was the outside. Okay, let's see which one is this. I click on it. Looks like that was region 1. So what I'm gonna SolidWorks now, I'm gonna press on this red forbidden sign. But notice the prompt, once I go over here, it says select all. So I click on this, select all of them for removal. And then I'm gonna say, do not remove this one. Region number 1. This is the one that's actually the dampener. I'm simply gonna click OK. Let's see the result. Pretty complex operation, but SolidWorks will be able to complete it successfully. And now it's just a matter of applying the material that you want. So let's say this material is gonna be rubber. Now we have the actual properties, we have the volume, we have the mass, we have everything we want. And let's get back to the assembly. And let's hide for a second the red part. And you can see this is the rubber that fits perfectly between the two of them. Now most likely we're gonna need some type of a scaling up for it to be just perfect. And this is the last turn in the race. I think I can see the pit stop, and if I'm not mistaken, I can see also Ivan. I just want to leave you with one more valuable piece of information. Free training you can get by simply going to the Javelin blog. Every day we write quite a few new tech tips, and also we have quite a lot of free training videos on the Javelin YouTube channel. So thank you very much for your time. And Ivan, back to you.
Hey, hello again. Welcome back. Wow, what a drive we just witnessed. Alin, thank you so much. Thank you so much for the expert job you did in taking us through that drive. I learned a lot of things. I'm sure you did too. You know, that's the thing about attending a user group meeting is you usually come away learning a lot of new things. I've been using SolidWorks for a long time, but it never fails when I watch a presentation, go to a meeting, there's something new that I learn, maybe a tool or a feature that I forgot about, maybe just another user's perspective on how they do things that helps me out as a SolidWorks user. So thank you so much for that. Before I leave, I just want to give a quick shout out to SLUGME, which is a SolidWorks user group network. What is that? Well, it's basically a group of user groups around the world. I mean, check out this map. It's unreal. Look at all those pins. We love to see pins. And if you've never been to a meeting before, I encourage you to check out the link there, swuggen.org. Check it out. See if there's a group near you. And go and attend a meeting. I'm sure you will not regret it. And if there's not a group near you, why don't you look into starting a group, becoming a leader? That's what I did. There was no group in our area, so I figured, you know what? We need a group. There's a lot of users. So I looked into it, and I'll tell you what, the people at SolidWorks, as well as many other user group leaders that are in the community, they were so helpful in starting out the group. It was not difficult at all. They gave me a lot of help, a lot of pointers. So a big shout out to all of them. You know who you guys are. And yeah, it's a fun time. It's a fun time leading a group. The group that I lead is called the SolidWorks User Group of Lethbridge. And we are located in Alberta, Canada. And if you look way up there on the map, that's our pin right there. That's us. So if you're in the area, come and drop by and say hi. That about does it for us for this segment here. So I am pleased and happy to turn it back to the racing broadcast crew of Dan, Cam, Todd, and Eric. Thank you guys.